Uh, Firstly, I'll introduce myself. My name is Shyam Rai. I am the assistant teacher of R.K.S.P Boys Higher Secondary School. So, I am doing in mathematics class 12. I am doing the very important topic, that is vector algebra, जो चाहिँ usually हामी 3 dimension मा गर्छौं हामी. Okay. Now, before going to this topic is very important, because usually in higher secondary examinations in HS you can easily score at least 7 marks from this topic, vector algebra. Now, first question distribution चाहिँ यस्तो हुन्छ. First मा आउँछ एउटा objective types, है, objective type question, है, त्यो चाहिँ तिमीहरुको 1 marks मा आउँछ. त्यो 1 marks मा आउँछ. तिमीलाई you are given 4 options, so you have to choose any one from that 4 options. अनि यो objective type question चाहिँ conceptual questions हुन्छ. That means you have to understand the theory part very clearly. So this objective type questions 1 marks. So चाहिँ हामीले इजिली स्कोर गर्न सक्छ. अनि अर्को आउँछ short answer type. त्यो चाहिँ आउँछ 2 marks मा. And this in the short answer type you are given 2 questions. From that 2 questions you have to choose any one. And last ma also number 3 ma long answer type जो चाहिँ 4 marks मा आउँछ. And you are given 2 questions and you have to choose any one. So 4 plus 2, 6 plus 1. That is, you can easily score at least 7 marks from this topic, vector algebra. Okay, students, today this is my first class. So, in this first class, today I'll only do the basic concept of the vector in mathematics. So, before going to the vector concept in mathematics, so first I'll give you the some of the concept of junior classes, vector concept in physics. As you all know, तिमीले class 9 मा गर्यौ, there are 2 quantities, physical quantities. अनि physical quantities भन्ने पनि याद छ. जो क्वान्टिटिजलाई हामी त्यसको मास मेजर गर्न सक्छ, त्यसको लेन्थ नाप्न सक्छ, त्यसलाई के भन्छ? फिजिकल क्वान्टिटिज. So there are 2 types of physical quantities. Number 1 is scalar and number 2 is vector. More details मा जादिन. What is a scalar? And as you all know, scalar quantities is the quantities which have only magnitude. तिमीलाई याद छ example पनि, suppose mass. तिम्रो मास कुनै पनि एउटा suppose this duster, है, यसको हामीले मास ताप्न सक्छ, यसको हामीले यसलाई वेट गर्न सक्छ, ओके हैन? So mass, suppose it is 10 units. Mass, suppose area is suppose 20 square units. Volume, suppose it is 125 cubic units. So all these mass, area, volume are scalar quantities because it has magnitude only, right? This numerical number, that is 10, 20, 125, these are the magnitude. So जसको म्याग्निट्युड मात्रै हुन्छ त्यसलाई के भन्छ? स्केलर. त्यो तिमीले जुनियर क्लासेसमा तिमीले पढिसकेको छौ. Now, so what is the vector? In physics, vector means vector quantities are the quantities which have both magnitude and directions. जसको चाहिँ के पनि हुन्छ, magnitude पनि हुन्छ अनि direction पनि हुन्छ हो. Now अब in this vector quantities, so you all know in everyday life there are many practical application of vector. So when suppose example कुनै पनि एउटा ball छ रे, when you hit the ball, तिमीले ball लाई hit गर्यो भने तिमीले force apply गर्छ है. Force apply गर्दा तिमीले कुन चाहिँ directions force apply गर्दा, suppose this duster. So when you apply the force apply गरे in this directions, so force is the के भयो vector quantity. किनभने यसको magnitude पनि हुन्छ, यसको direction पनि हुन्छ. अनि जब यसलाई मैले force apply गरे भने there exists a displacement, and the very important part in vector is displacement vector. So displacement है जसको direction हुन्छ, यता मैले force यता apply गरे भने यो यतापटि displace हुन्छ, मैले force यता apply गरे भने यो यतापटि displace हुन्छ. That means this force, displacement are all vector quantities. Velocity is vector quantities, acceleration is vector quantities, momentum is vector quantities. त्यो चाहिँ तिमीले क्लास 9 मा पढिसकेको छौ ओके न. अब now, so what is the vector in mathematics? So what is the vector in mathematics? Mathematics मा vector के हो? Physics को जस्तो जसको magnitude हुन्छ अनि जसको direction पनि हुन्छ. So vector in mathematics, actually in mathematics a directed line. In mathematics a directed line is called a vector. Mathematics मा चाहिँ के हो? A directed line is called a vector. So मैले एउटा दुईटालाई, suppose यो line, this line is L1, so L1 is directed in this direction, right? And this line is L2, and this line is directed in this directions. यो direction मा directed हुँदैछ L1, L2, यो in downward direction मा directed हुँदैछ. So these are the directed line. So you कहाँसम्म directed? This line is directed towards the infinity. This L2 line is directed towards the infinity. Now I'll take the 2 points. This is A and B on the line L1. On L2 I'll take the 2 points C and D. So यो A र B लाई म अलग्गै निकाल्छु है. This line A and B. Okay, I'll got it. This is A, this is B, and this is C, this is D. Okay. म यो L1 लाइन हुन्छ नि जुन चाहिँ त्योबाट यो AB जुन चाहिँ AB पार्ट छ त्यसलाई अलग्गै निकाल्दाखेरि मेरो यस्तो हुन्छ. This line AB. This is also the directed line. तर यो लाइनको लेन्थ हामीले मेजर गर्न सक्छ. यो लाइनको लेन्थ हामीले मेजर गर्न सक्छ. That means this line AB has the magnitude. Measure गर्नु सक्छ हामीले. This line has the के हो यो यसको के छ magnitude छ. This line have the magnitude. जसलाई हामीले नाप्न सक्छ. And this line is directed from A to B. So therefore this line AB is called the line AB is called the vector. This is which is denoted by vector AB. यसलाई किन vector AB लेख्यो भने यो AB line को हाम्रोमा के छ sense छ. Sense means this line is directed from A to B. This line is directed from A to B. I had given the directions like this. This line is directed from A to B. So this line has the sense. है अनि यसको हामीले लेन्थ नाप्न सक्छ. लेन्थ नाप्न सक्छ. एउटा सर्टेन एउटा स्केलर पाउँछ हामीले द्याट मिन्स यसको म्याग्निट्युड पाउँछ है सो यसको म्याग्निट्युड पनि छ यसको डिरेक्सन पनि छ सो दिस लाइन एबी इज कल्ड द भेक्टर एबी एन्ड युजली भेक्टर इज हामीले यसलाई एबीलाई हामीले एबी माथि एरो लेख्न सक्छ एन्ड दिस युजली भेक्टर इज डिनोटेड बाई हामीले स्मल लेटरमा एबी स्मल लेटर ए एबी भेक्टरलाई यु क्यान राइट दिस भेक्टर ए के लेख्न सक्छ अर यसलाई मैले के रिप्रेजेन्ट गरेँ इट इज रिप्रेजेन्टेड बाई द स्मल ए भेक्टर बुझ्यो कुनै पनि लाइन छ जसको डिरेक्सन छ डिरेक्टेड लाइन जसको डिरेक्सन छ जसको म्याग्निट्युड छ त्यसलाई के भन्दछ भेक्टर एन्ड युजली म्याथमेटिक्समा चाहिँ अ डिरेक्टेड लाइन इज कल्ड भेक्टर एन्ड दिस लाइन एबी has the support, this L1 is the support. Similarly CD, this line CD, this is acting downward directions from D to C, from D to C. So this DC, this is called vector DC, this is called vector DC because this line is related from D to C and you have small letter you can represent it in the small letter, so I can take small d. You have small d. So vector mathematics ma ke rahcha bhane the vector is simply a directed line jasko magnitude huncha as well as direction pani huncha. Okay, first now I will go to the next topic, that is magnitude. Magnitude of a vector. Magnitude of a vector. Suppose this is a vector, AB is a vector in these directions. Just like I represent gareko small a. Small a is the vector, right? This line is related from A to B. So what is the magnitude of a vector means? You are defined it is the distance from distance of the 2 points, that is A देखि यहाँ B सम्मको distance लाई भन्छ magnitude of a vector. Magnitude of a vector. So magnitude of a vector is denoted vector AB. This is vector AB, or you are represent very small letter vector A. This magnitude of vector I have already defined you. This AB is the distance of the point A from B. Isko distance la hamle ke bhancha magnitude, and as you all know the distance is always positive. So magnitude of a vector is denoted by magnitude of vector is denoted by modulus of vector AB. Modulus of vector AB, because you have to take the modulus sign, because the magnitude of vector is always greater than equals to 0. Modulus of vector AB or modulus of vector A, and this is always greater than equals to 0. So this is the magnitude of a vector. Just like हामीले नाप्नु सक्छ. And this vector is related from A to B. So this is very important, magnitude of a vector. Now I'll go to the another important topic, that is different types of vector. Now, so first I'll go to the zero vector. Number 1, different types of vector. Different types of vector. So number 1 is zero vector, or we can call it null vector also. Null vector. Vector ka maile agi नै भने suppose this is the vector AB. Vector AB directed from AB, directed from A to B. And this A is called, you point A like हामीले भन्छ, this is called tail of a vector. Tail of a vector, or you can call it initial point भन्छ, यसलाई के भन्छ initial point of a vector. Because this vector is related from A to B. Initial point, or you can call it tail of a vector. Tail of a vector. Tail of a vector. And B, this is called the terminal point. This is called the terminal point. And the measurement of the initial point and the terminal point, distance is magnitude. I have already discussed earlier. Now, this is initial point or tail of a vector. Right? Now, so what is the zero vector? So, zero vector भनेको चाहिँ के हो भने हामीलाई याद हुनुपर्छ vector initial point and terminal point, that is tail of a vector. Zero vector, what type of a vector? You can call it a zero vector. भन्दाखेरि if the initial point and terminal point coincide, if the initial point and बुझिहाल्यो तिमीले initial point जहाँबाट point start हुन्छ त्यो direction मा त्यसलाई भन्छ initial point, जहाँ point finish हुन्छ है त्यसलाई भन्छ terminal point. So what is null vector means? Null vector or zero vector. If the initial point and terminal point coincide, if the initial point and terminal point coincide, then that type of vector is called zero vector. Suppose I give the point, this one, here, you can call it zero vector because their initial point and terminal point coincide. Right? कुनै पनि हेर सर्कुलर पाथमा यसरी मुभ भयो भने यहाँदेखि स्टार्ट गरेर तिमीले यहाँसम्म फेरि यहीँ आयो भने that means initial point and terminal point coincide हुँदैछ. Initial point and terminal point के हुँदैछ? Coincide. That means initial point र terminal point को distance के हुँदैछ? 0 हुँदैछ. Initial point and terminal point को distance के हुँदैछ? 0 हुँदैछ. त्यति बेला भन्छ that type of vector is called zero vector or null vector. And usually तिमीले क्लास 9 मा फिजिक्स मा पढेको जुन चाहिँ ठाउँबाट स्टार्ट गर्दैछ त्यही ठाउँमा आयो भने त्यति बेला डिस्प्लेसमेन्ट 0 हुन्छ है. एन्ड त्यति बेला इनिशियल पोइन्ट एन्ड टर्मिनल पोइन्ट कोइन्साइड भने डिस्प्लेसमेन्ट 0 हुन्छ. सो दिस इज कल्ड जीरो भेक्टर एन्ड इट इज डिनोटेड बाय 0. बिग O, it is denoted by 0. Actually, zero vector does not have particular directions. Zero vector does not have particular directions because तिमीले याद छ force is also vector quantity. So यहाँबाट 0 न्युटनको फोर्स यहाँदेखि एप्लाई गर्न सक्छु म, यहाँदेखि एप्लाई गर्न सक्छु, यहाँदेखि एप्लाई गर्न सक्छु in this direction also. So actually the zero vector does not have any particular direction. So हामीले since 0 is also zero vector, so you can call it like this is also the zero vector. 0 को माथि हामी के लगाउँछ arrow. And actually zero vector does not have specified or particular directions. बुझ्यो? And what is zero vector? That means initial point and terminal point coincide भने you can call it zero vector. Okay. Another most important type of vector is unit vector. Unit vector. Unit vector. And this unit vector is very, very important. In the next class, in the coming classes, this unit vector give the direction of the vectors. Unit vector बाट चाहिँ हामीले यसले कहाँपट्टि vector direct हुँदैछ त्यो हामीले थाहा पाउन सक्छ. You can easily. So what is the unit vector? So त्यही magnitude को कुरा आउँछ है. If the magnitude of the vector, suppose यहाँनिर हाम्रो AB छ, vector AB है, in this direction, suppose यसको magnitude, that is distance from A to B, यसको magnitude चाहिँ कति भयो रे 1 भयो भने this type of vector is called the unit vector. This type of vector is called the unit vector. अब म 2 डाइमेन्सन युनिट भेक्टर बुझ्यो जसको म्याग्निट्युड चाहिँ कति हुन्छ 1 हुन्छ that type of vector is called the unit vector. अब unit vector को concept में 2-dimensional system मा later on I'll move to the 3-dimensional system also. Now 2-dimension मा म सब concept अलिकति म गर्दै राख्छु. Suppose this is x axis and this is y axis. कुनै पनि point x axis मा यसरी मुभ भयो. यहाँनिर कोअर्डिनेट a छ रे. This is origin. a को कोअर्डिनेट छ 1,0 1,0 अनि towards the y axis यहाँ b छ. b को कोअर्डिनेट छ x 0 छ, y चाहिँ कति छ 1. That means यहाँ हेर तिमीले there the distance of a from the origin, that is OA. What is the magnitude of OA? What is the magnitude of OA? हाम्रो के हुँदैछ 1 unit. And what is the magnitude of OB? Magnitude of OB, distance of the point B from the origin, यो पनि कति हुँदैछ 1 unit. And this line is directed to this is vector because in this direction मा यो directed हुँदैछ. यसको magnitude पनि छ 1 unit. In this direction मा यो उस हुँदैछ, move हुँदैछ. यसको magnitude छ 1 unit. And actually this OA is called a unit vector. यसलाई के भन्छ हामी? This is called unit vector along x-axis. This is called unit vector along x-axis. And OB, जिसको magnitude कति छ 1, and we can call it, this is called unit vector along y-axis. Unit vector along y-axis. अनि so vector मा चाहिँ unit vector along x-axis लाई हामीले केले डिनोटेट गर्छ I cap, and unit vector along y-axis it is denoted by z cap. Similarly, हाम्रो अर्को डाइमेन्सन अर्को प्यारामिटर थप्यो z थप्यो भने युनिट भेक्टर अलोङ z एक्सिस 3-डाइमेन्सनल सिस्टममा यु क्यान कल इट k भेक्टर. सो I भेक्टर भन्ने बित्तिकै याद गर्नु I क्याप देख्ने बित्तिकै याद गरिहाल्नु द भेक्टर इज मुभिङ टुवर्ड्स x एक्सिस. अ पोइन्ट इज मुभिङ टुवर्ड्स x एक्सिस. अनि j क्याप भन्ने बित्तिकै याद गर्नु a point is moving towards y axis. And k cap भन्ने बित्तिकै याद गर्नु the point is moving towards z axis. Later on हामी यो different formula prove गर्दा I'll go through the details of this all unit vectors. Okay, so यसरी हामीले unit vector लाई मैले 2 डाइमेन्सनमा मात्रै देखाउँदैछु. This is called I cap and j cap. किनभने हामीले यस्तो गर्न सक्छौं यहाँ र यही डाइमेन्सन अफ भेक्टरलाई यसरी गर्न सक्छ इन दिस भेक्टर नोटेशन्स. सपोज यही छ, सपोज एउटा पोइन्ट ए मुभ भयो, यसको डिस्टेन्स छ 2 युनिट भनेपछि यो कति छ 2. ओ देखि यसको सम्म डिस्टेन्स दैट इज ए इज डिस्प्लेस्ड टुवर्ड्स पोजिटिभ डाइरेक्सन अफ एक्स एक्सिस. ए इज डिस्प्लेस्ड, ए इज मुभिङ टुवर्ड्स द पोजिटिभ डाइरेक्सन अफ एक्स एक्सिस. कतिले 2 युनिटले. सो इन टर्म्स अफ भेक्टर ओए लाई हामीले लेख्न सक्छ यु क्यान कल इट 2i cap. 2i cap because I cap is a unit vector. And 2i cap means a point is moving 2 units to the positive direction of x axis. If a point is moving suppose B is the point is moving, यहाँ देखिको यहाँ distance or magnitude छ 3 units, then OB लाई हामीले लेख्न सक्छ you can write 3j cap. So in terms of vector component मा हामीले यसरी लेख्न सक्छ. So this unit vector is very important. It gives the direction of the vector because 3j cap भन्ने बित्तिकै याद पाइहाल्नु a point is moving 3 units towards the y axis. So unit vector is very important. And usually in HS questions, in J questions, तिमीलाई unit vector खोज्ने आउँछ. Unit vector. Find the unit vector. Find the unit vector in the direction of the given vector. अब what? How you can find a unit vector? त्यो पनि डिस्कस गरिहालौँ. How you can find a unit vector? Suppose OA vector छ मेरो 2i cap. OA vectors are 2 I cap. So what is the modulus of OA? And here this is 2. Modulus of OA is 2. The distance from the point A, from the origin is OA is 2. So what is the unit vector of OA? What is the unit vector of OA? What is the unit vector of OA? भन्नेको मतलब OA लाई vector OA लाई त्यसकै modulus vector OA लाई, that is 2I लाई त्यसकै modulus ले divide गर्यो भने you will find I cap, you will get I cap. So that is the unit vector. So generally you formula याद गरिराख्नु. What is the unit vector of vector A? So हामीले vector A लाई त्यसकै modulus ले के गर्नुपर्छ? Divide गर्नुपर्छ. त्यति बेला हामीले you can find a unit vector. You can easily find the unit vector by using this formula. कुनै पनि vector दिएको छ त्यसलाई त्यसकै modulus ले, त्यसकै magnitude ले divide गर्यो भने you can easily find the unit vector. तर sometimes यस्तो क्वेशन पनि आउँछ युनिट भेक्टरबाट. एउटा भेक्टर दिएको हुन्छ. सपोज AB is the vector, है, AB is the vector. Find a vector of find questions here. Find a vector of 6 magnitude. Find the vector of unit vector को concept में. Find a vector of 6 magnitude in the direction of vector AB. In the direction of vector AB. In the direction of vector AB. This type of questions frequently asked हुने questions हरु यो. So vector AB मा हामीले अर्को vector खोज्नु अरे जसको magnitude चाहिँ कति छ अरे 6 units. जसको magnitude चाहिँ 6 units. यही direction मा in the direction of vector. त्यो चाहिँ कसरी मात्रै find गर्नु सक्छ भने जब हामीले this is very very important. AB को हामीले के खोज्नु पर्छ? युनिट भेक्टर खोज्नु पर्छ. भेक्टर AB को के खोज्नु पर्छ? युनिट भेक्टर खोज्नु पर्छ. अनि त्यसलाई 6 ले मल्टिप्लाई गर्यो भने you can easily get the required vector. That means the first process is you have to find the unit vector of AB. Unit vector of AB. Vector AB. And as you all know, you can easily find the vector unit vector of AB, that is vector AB लाई त्यसकै मोडुलस ले डिवाइड गरेर यसलाई युनिट भेक्टर पाइहाल्छ. यसको AB को युनिट भेक्टर पाएपछि त्यसलाई 6 ले मल्टिप्लाई, दैट इज वी फाइन्ड अ भेक्टर अफ 6 मैग्निट्युड. सो 6 ले मल्टिप्लाई गरे भने you can easily find the required vector. Therefore required vector के हो त्यो कति हुन्छ हाम्रो? Required vector is equals to 6 into vector AB divided by modulus of vector AB. So यसरी हामीले you can easily find the required vector. याद गर्नु, find the vector of 6 magnitude in the direction of vector AB. Vector A, vector B small letter मा दिएको हुन्छ. त्यति बेला पहिला फर्स्ट जुन चाहिँ गिवन भेक्टर दिएको छ त्यसको युनिट भेक्टर खोज्नु अनि त्यसलाई कति म्याग्निट्युड, कोही बेला 6 हुन्छ, कति बेला 7 हुन्छ, त्यसले मल्टिप्लाई गर्यो भने यु क्यान इजिली फाइन्ड द रिक्वायर्ड भेक्टर. सो युनिट भेक्टर इज भेरी भेरी इम्पोर्टेन्ट. जसको म्याग्निट्युड 1 हुन्छ त्यसलाई युनिट भेक्टर हुन्छ है. मैले 2 डाइमेन्सनल सिस्टममा पनि देखाएँ, 3 डाइमेन्सनल सिस्टममा पनि. लेटर अन यु गो टु डिटेल्समा जान्छ हामी. नाउ and unit vector give the directions of the vectors and you can easily find the unit vector. And yesto khalko question are find the vector of 6 magnitude in the direction of given vector. Teti bela pani unit vector is very very important. So this is very very unit vector is very very important. Jusko magnitude 1. So another vector is, I'll go to the next vector that is called negative of a vector. Negative vector. This is number 3. Negative vector. So negative vector is also the important in terms of vector addition also. So that negative vector is also important. Abo, suppose your vector, this is AB is the vector directed from A to B, and CD is the vector. CD is the vector directed from D to C. If the magnitude of AB vector is equals to magnitude of, this is DC vector, because this vector is directed from D to C, इसको magnitude to equal छ है यहाँ दुईटा मैले vector देख्छु AB and DC. DC means this vector is directed from D to C. यसको magnitude चाहिँ equal छ है, यसको length equal छ, but the direction are in opposite direction. यो direction मा जाँदैछ, यो direction मा जाँदैछ. Then vector DC, then the vector DC is called the negative vector of AB. यसलाई के भन्छ? Negative vector of AB. Vector DC is called the negative of vector AB. यसको magnitude equal छ, but opposite direction मा छ भने that type of vector is called the negative vector. कुनै पनि vector यहाँदेखि यहाँसम्म vector B छ अरे, बुझ्यो? अनि फेरि यो vector फेरि यो direction मा छ, तर यो direction मा यसको magnitude, this max suppose OA, this is OA and this is OB, जिसको OA is equals to, this OA is equals to OB, magnitude equals to, direction opposite मा छ, then OA is represented by vector B, then OB is represented by, this is minus of vector B. So this is negative vector, जिसको magnitude to same हुन्छ, but direction चाहिँ are in opposite direction. So this is called the negative of a vector. बुझ्यो तिमीले? Now number 4, co-initial vector. Co-initial vector. Students, today I'll only go through the theory parts only, because theory parts is very, very important. So what is co-initial vector means? Suppose you have the vector OA, OP, right? Vector OP, OQ, so you have the vector OP, vector OQ, and vector OS. All this, see in the figure, all these three vectors को tail छ नि, जुन चाहिँ initial point or कि tail of the vectors एउटा common point छ, जसको tail छ नि, यो coincide भएको छ सबैको. All the three vectors have the common initial point. All the three vectors have the common initial point. जस्तै OP को O छ, tail of the vector, OQ को पनि tail of the vector O छ, OS को पनि के छ, O छ. So this type of vector is called the co-initial vector. यसलाई के भन्दैछ? Co-initial vector. means there are different types of vector को चाहिँ जुन चाहिँ एउटा initial points चाहिँ same हुन्छ, त्यसलाई भन्छ हामी co-initial vector. And number 5, the very important part, यहाँबाट questions पनि तिमीलाई सोधिनु सक्छ. Number 5 is collinear vector. Number 5 is collinear vector. So collinear concept is very, very important, because मैले भनिहालेँ vector algebra 3 dimensional किन important छ भने, after finishing this topic vector, you have to move to the next topic, that is straight line, 3 dimension and plane. अनि यो vector को concept हामीलाई चाहिन्छ, त्यो टपिकहरु straight line, that is equation of straight line मा पनि हामीले vector को concept चाहिन्छ है, the equation of plane मा पनि vector को concept चाहिन्छ. So this vector algebra is very, very important. Now collinear vector. So what is the collinear vectors भन्दाखेरि चाहिँ, so if you have the vector This is AB, this is CD, okay, this is RS. You have the three vectors, that is vector AB, CD, and vector RS, vector SR, sorry, vector SR. So, all these see in the figure, all these three vector are parallel to each other. All these three vector are parallel to each other, and all these three vector are parallel to the fixed line. All these three vector are parallel to each other, and all these three vector are parallel to the fixed line. This type of vector is called a collinear vector. No matter the directions, direction same हुन्छ no matter the directions, no matter the magnitude. Magnitude same हुन्छ भन्ने पनि छैन, direction same हुन्छ भन्ने पनि छैन. जस्तै AB, vector AB and CD have the same directions, but vector SR have the opposite direction, but they are collinear vectors. यसलाई के भन्छ? Collinear vectors. They are parallel to each other. Suppose your vectors are these vectors and these vectors. These two vectors are not collinear. They are not parallel, because this vector is parallel to fixed line and this vector is parallel to another line. So vectors को लागि चाहिँ they should be parallel. They should be parallel to it. त्यसलाई हामीले direction सँग मतलब छैन, magnitude सँग मतलब छैन. And what is the condition for collinear vectors? So this is very, very important. So vector AB and CD, vector AB and vector CD are collinear. It's a collinear. So हामीले vector AB लाई you can write vector AB is equals to lambda times lambda into vector CD, lambda being some scalar, some non-zero, lambda being some scalar. यो चाहिँ किन हुन्छ भने यहाँ see in the figure जस्तै AB को magnitude CD को magnitude different छ, AB को magnitude र CD को magnitude different छ. Magnitude means actually the length, distance between the 2 points. Now यदि मैले lambda ले multiply गरे भने lambda being some scalar, यो lambda ले multiply गरे भने यो दुईटाको magnitude equal हुन सक्छ. So you can write vector AB is equals to lambda times CD. यति बेला हामीले lambda is some non-zero scalar, lambda ले multiply गरे भने you can यसको जग्गामा हामीले x राख्न सक्छ, y राख्न सक्छ. multiply गरे भने यो दुईटाको magnitude के हुन्छ? Equal हुन्छ. So if vector AB and CD are collinear, so vector AB can be written as lambda times vector CD. Lambda times vector CD. So this is a very, very important result for collinear vectors. अब यो केसमा पनि दुईटा छ. If lambda is positive, if lambda is positive, जब lambda positive भयो भने you have to remember that this vector AB and CD have the same direction. Vector AB and CD have the same directions. If the lambda is negative, then vector AB and vector CD. If lambda is positive, vector AB and vector CD have same direction हुन्छ यो, have the same directions. Suppose कोही बेला lambda is negative, if lambda is negative त्यति बेला याद गर्नु vector AB and vector CD have opposite directions, So this is a condition for collinearity. Vector AB is equals to lambda times CD. If lambda is positive, vector AB and CD have same directions. If the lambda is negative, then these two vectors are in opposite directions. अनि यो केसमा पनि दुईटा छ, जब vector AB and CD have the same directions, त्यतिबेला भन्छ they are called like vectors. They are called like vectors. Here in the figure, vector AB and CD have the same directions. They are like vectors. These two are like vectors. These two are like vectors. Here vector SR, they have the opposite directions. So this is unlike vectors. This is unlike vectors. So like vectors means if the two vectors are parallel and they have the same directions, such type of vectors are called the like vectors. If the two vectors are parallel to each other but they have opposite directions, they are called unlike vectors. So this collinear vector is very important. किनभने यो सर्ट एन्सरमा पनि क्वेसन सोध्नु सक्छ and later on straight line मा पनि काम लाग्छ यो. So this collinear vector is very important. Okay, now free vector. So what is the meaning of the free vector? So suppose you have the vector AB. योलाई भेक्टरलाई हामीले प्यारेलली डिस्प्लेस गर्यो, माथि प्यारेलली डिस्प्लेस गर्यो. दिस इज भेक्टर एबी. यो भेक्टरलाई मैले के गरेँ, प्यारेलली डिस्प्लेस गरेँ कि त यही भेक्टरलाई मैले सेम डिरेक्सनमा सेम स्ट्रेट लाइनमा डिस्प्लेस गरेँ. दिस टाइप अफ भेक्टर इज कॉल्ड द फ्री भेक्टर विदाउट एफेक्टिङ इट्स म्याग्निट्युड. सबैको म्याग्निट्युड सेम छ. यु क्यान कल इट सिडी, यु क्यान एएफ. यसको म्याग्निट्युड सेम छ. यसलाई डिस्प्लेस यही भेक्टर एबीलाई नै मैले डिस्प्लेस गरेको प्यारेलली, यही भेक्टर एबीलाई नै डिस्प्लेस गरेको इन द सेम डिरेक्सन स्ट्रेट लाइनमा, जसको म्याग्निट्युड चाहिँ विदाउट एफेक्टिङ इट्स म्याग्निट्युड. दिस टाइप अफ भेक्टर इज कल्ड द फ्री भेक्टर. बुझ्यो? सो एक्चुअली भेक्टर इन म्याथमेटिक्समा चाहिँ के रहेछ, इट इज सिम्पली अ डिरेक्टेड लाइन having magnitude and directions. Okay, now the very important part is position vector. The very important part is position vector. So if P be the fixed point, and O is the, suppose O is also the fixed point. So suppose O is taken as the origin. So if we join this OP, P is the fixed point. If we join this, suppose this OP, so I will represent this vector R. Then this vector R is the position vector of P. With respect to O as a origin. Kuनै point एउटा fixed छ, O is also the fixed point. Suppose O is taken as the initial point, P is taken as a terminal point. यो दुईटालाई join गर्यो अनि यसलाई direction used from O to P, that is this is called the net displacement, जसलाई चाहिँ हामीले vector R ले represent गर्यो. This vector R is the position vector of P with respect to O as a origin. तर यहाँ कुनै पनि हाम्रो 2 points are. You have the 2 points A and B. Suppose O is the origin. यसरी join गर्दै मैले OA. So suppose the position vector of A is vector A and the position vector of B is vector B. And what is position vector of A? Position vector of A is A. Vector A is a position vector of A with respect to O as origin. vector small vector B is the position vector of B with respect to O as a origin. So what is the position vector of AB? So what is the position vector of AB? त्यति बेला के हुन्छ? What is the position vector of AB? Actually the position vector of AB लाई चाहिँ हामी लेख्छ simply यो फर्मुला याद गरे हुन्छ तर सिम्पल म त्यो प्रुफ पनि गर्दिन्छु. Position vector of AB is position vector of B minus position vector of A. So what is the position vector of B? It is B minus A. This is B minus A. अब यो चाहिँ कहाँबाट प्रुफ हुन्छ भने वेक्टर एडिसनको म साइमल्टेनियसली एकैचोटी गराइदिन्छु. वेक्टर एडिसन हामी दुई प्रकारले गर्न सक्छ. नम्बर 1 इज triangle law of vector addition, and number 2 is parallelogram law of vector addition. I think most of the students, they have already learned this vector additions in physics in class 11 topic. Actually, what is triangle law? Suppose you have the two vector, this vector, this is OA, this is vector A, and you have the vector, this is vector B, right? This is vector B, and this is vector A. In these directions and in this direction, you don't say vector B could tail line more. So this is the tail of vector A. This is the tail of the vector A, and this is the terminal point of the vector B. You tail of the vector A like vector B चाहिँ म यहाँ join गरिदिन्छु, freely displace गरिदिन्छु free vector, like the free vector यहाँनिर vector B गरे भने चाहिँ this is vector B, this is vector B. अनि suppose this is O A B, then vector मा most important is the measurement of the initial point and final point. यो point कसरी displace हुन्छ from O to A, vector A ले, from A to B, vector B, and this OB is called the net displacement vector. This OB is called the net displacement. जसलाई चाहिँ हामीले triangle law use गर्न सक्छ. So this third side represent the resultant of these two vector, that is vector A plus vector B. That is vector OA plus vector AB is equals to vector OB. So this is vector A plus vector B is equals to A plus B. So this is a triangle law of vector additions. अनि यो पोजिसन भेक्टरमा हामी ट्रायंगल ल युज गर्न सक्छौं किनभने यहाँ हेर पॉइंट यहाँदेखि यहाँसम्म डिस्प्लेस हुँदैछ बाइ द भेक्टर A. So that means this vector OA plus vector AB from A to B फेरि डिस्प्लेस हुँदैछ AB is equals to, this is the net displacement, that is B, and vector OA कति छ हाम्रो A छ, this is vector AB is equals to vector B. So therefore vector AB is equals to vector B minus vector A. So you can easily find the position vector of A and B if the point A and B lie in the plane. Okay, actually position vector of AB is position vector B minus position vector of A. यो चाहिँ हामीले triangle law of vector addition ले गर्न सक्छ. If the two sides of the triangle, adjacent side of the triangle, represent the vector A and B, then the third sides represent the resultant of these two vectors. यो हामी सजिलैसँग प्रुभ गर्न सक्छ किनभने मैले यस्तोले योलाई प्रुभ गर्दा सिम्पल छ. म प्यारालेलोग्राम ल भेक्टर एडिसन गर्दिन किनभने दिस ल इज अल्सो फलो द सेम ट्रायंगल ल भेक्टर एडिशन्स. त्यति बेला चाहिँ त्यो डायगोनलले रिप्रेजेन्ट गर्छ दुईटा भेक्टर साइड्सको, दुईटा प्यारालेलोग्रामको एडजेसेन्ट साइडको रिजल्टेन्ट. यहाँनिर मैले के लेख्न सक्छु भने यो कसरी प्रुभ गर्छ भने भेक्टर OA प्लस AB प्लस BC इज इक्वल्स टु 0 लेख्न सक्छु म 0 भेक्टर यु क्यान से 0 किन यहाँदेखि पोइन्ट O to A जाँदैछ A to B फ्रम B to C फ्रम B to C फ्रम B to O सरी फ्रम B to O O to A to B अगेन फ्रम B to O यहीँ आयो नि है द्याट मिन्स तिमी यहीँदेखि इनिसियल पोइन्ट यहाँबाट स्टार्ट गरेको यहीँ आयो भने त्यति बेला के हुन्छ 0 हुन्छ है एन्ड 0 हामी O इज भेक्टर A AB इज भेक्टर B एन्ड BO लाई हामीले लेख्नु दिस इज माइनस अफ BO द्याट इज भेक्टर A प्लस भेक्टर B एन्ड नेगेटिभ अफ माइनस अफ BO इज दिस इज OB. So this OB represent the resultant of this two vector, that is the sum of two vectors. And this law, parallelogram law of vector addition also followed from the same rule, that is triangle law of vector addition. अनि vectorले always follow गरेको हुनुपर्छ this triangle law of vector addition. So हामीले position vector मा याद पाइहाल्यो there are two types of vector additions, one is triangle law of vector additions, another law is parallelogram law of vector additions. Now we have the different properties of vector addition. Vector addition को हाम्रो different properties छ त्यो properties मा number 1 हुन्छ vector addition. Vector addition is always commutative. Vector addition is always commutative. That is, vector A plus B is equals to vector B plus vector A. If vector A plus B is equals to vector B plus A, then vector addition is always commutative. यो दुईटा के दिए always occurs the equality condition follow गर्यो भने vector addition के हुन्छ commutative. That is, यसलाई हामी simply number लेख्नु 2 plus 3 is always equals to 3 plus 2 in terms of number. So vector addition is always commutative. The proof is very simple, you can go through the books also. And number 2, vector addition is associative. So for the associativity you require 3 vectors, that is vector A plus vector B plus C is equals to vector A plus B plus C. If this result follows, then vector addition is associative. Number 3, existence of additive identity. Existence of additive identity. Number 3 is existence of additive identity, and number 4 is existence of additive inverse. Existence of additive inverse. So these are the 4 properties, that is vector addition is commutative, vector addition is associative, and number 4 is existence of additive identity. And what is the meaning of existence of additive identity is very simple. कुनै पनि भेक्टरमा अर्को भेक्टर एड गर्यो भने सेम भेक्टर पाउँछ. So what is this required vector? Then you all know this is 0 vector. This is 0 vector. कुनै भेक्टरमा 0 vector add गर्यो भने you will get the same vector. So this 0 vector is called the additive identity. This 0 vector is called the additive identity of the vector A. And similarly, 0 vector plus vector A is also vector A. So 0 vector is called the additive identity. And what is the meaning of additive inverse? कुनै पनि vector given vector छ त्योसँग अर्को vector add गरे भने you will get the 0 vector. So what is the required vector? Then obviously you know vector A यसको negative vector add गरे भने हामीले के पाउँछ 0 vector. Similarly the negative vector plus the given vector you will get the 0 vector. So this minus of vector A is called the additive inverse of the vector A. So this is only the theory part. This is only the properties of vector addition. Okay. So these are all about the basic concept about the vectors and vector additions. So now in the next class we will do, there are three types of multiplication of vectors. One is हामी next class मा के गर्छौं भने multiplication of vectors गर्छ, position vector in 2 dimensional, position vector in 3 dimensional पनि गर्छ and different formula पनि derive गर्छ. Okay, so this is all about my first class for the vector. So in the next class I'll do multiplication of vectors. That is first multiplication vector is multiplication of vectors by a scalar. Then I'll go to the dot product and cross product. Okay, this much for today.